শনিবার বলেছিলাম।
আমি তো সেটাই ভাবছিলাম যে আমরা ইন্টারনেট সেটা তো যদি ওদের সমস্যা হয় বা কিছু ওরা একসঙ্গে পরেও করে নেওয়া যেতে পারে ক্লাসটা।
হ্যাঁ, আমি তো ওদের শনিবার, দেখ আমি ওদের ক্লাসরুমে নোটিশ দিয়ে রেখেছি শনিবার। আমাকে প্রসূন বলল যে ওরা স্যারের সাথে কথা বলেছে, আমি আজকে এটা নিতে পারি, শনিবারে ওরা কেউ ক্লাস করতে চাইছে না, তো সেই জন্য। তা না হলে আমি বারবার ওদেরকে বলেছি যে উনি গেস্ট ফ্যাকাল্টি, ওনার টাকা নিয়ে সমস্যা।
শনিবার তো দেখ অফিসিয়ালি তো ছুটি হয়, সেটা ওদেরকে বলতে হবে। তাহলে তোমরা যদি ওইভাবে একসঙ্গে যদি চাও তাহলে শনিবারই তাহলে আমরা করাবো, বা বলবে যে আমি শনিবার দিন এই সময় ক্লাসটা নেবো।
আরে আমি শনিবার 11টা থেকে ওদের টাইম শিডিউল সব বলে রেখেছিলাম, এটা ওরা করেছে। ওরা বলেছে, ওরা স্যারকে বলেছে ওরা সোমবার বিকেলে করে নেবে। তারপরে ও প্রসূন আমাকে জানিয়েছে, আমি ওকে বারবার ওদেরকে বলেছি। ঠিক আছে, আমি তো এখন আপাতত ক্লাসে ঢুকে গেছি, আমার তো আজ 10টা বাজতে 1 মিনিট। আজকের দিনটা মানে ওনাকে একটু ম্যানেজ করে নিতে বল। 12টা পর্যন্ত। ওনারও 12টা।
ওনার কি মানে কটা থেকে কটা?
ওনারও 10টা থেকে 12টা।
10টা থেকে 12টা। তাহলে কি আজকের দিনটা
আজকেরটা ওনাকে বল এই সপ্তাহের জন্য উনি যেন শনিবার নিয়ে নেন, আমি আজকে নিয়ে নিচ্ছি। কম্বাইন্ড মানে কম্বাইন্ড ওনাকে নিতে হবে না, উনি তো এ সেকশন ছিল, উনি এ সেকশনটা যেন শনিবার নিয়ে নেন। অন্য দিনগুলো যেরকম যেরকম ওনার নেওয়ার কথা সেরকম সেরকম উনি নেবেন। আর আমি পরের সপ্তাহ থেকে শনিবার কম্বাইন্ড ক্লাস নেব। আর আমি ওদের কথা শুনবো না, ওরা ভীষণই মানে আমি ওদের বারবার বলেছি। আমি তো তোকেই সবার আগে ইনফর্ম করেছি, আমার মাথায় যদি না জিনিসটা আসতো আমি নিশ্চয়ই তোকে ইনফর্ম করতাম। না না, কোনো সময় আমার কেন সমস্যা থাকবে? আমি তো শনিবার, বরং আজকে আমার, তুই জানিস না আজ আমার 10টা থেকে শুরু হয়েছে, আমার আজকে 5:30টায় শেষ। মানে আমি এই 12টা পর্যন্ত নেব, আবার 12টা থেকে একটা থিওরি দুটো, আবার 2:30টা থেকে আবার স্পেশাল প্রজেক্ট। আমি তো বরং শনিবার গেলে আমার সুবিধা। হ্যাঁ, আমি এই ক্লাসে বলে দিচ্ছি। আর আমি তো আজকে তো কিছু করার নেই, আমি অলরেডি ঢুকে গেছি, ওরাও ঢুকে গেছে আজকে। হ্যাঁ হ্যাঁ নিন, উনি যেন আজকের যে ওনার সেকশন ছিল উনি ওটা শনিবার নিন, আর তাহলে উনি 6টা ক্লাসই পেলেন। আর নেক্সট উইক থেকে আমি 11টা থেকে শনিবার নেব, আমার কোনো অসুবিধা নেই। ঠিক আছে, তুই প্লিজ একটু ফোন করে দে। আমার ওনার কাছে ওনার ফোন নাম্বার আমার নেই এখন, আমাকে তাহলে আবার ওনার ফোন নাম্বার জোগাড় করে ওনাকে কন্ট্যাক্ট করতে হবে। হ্যাঁ, আমি তো ওনাকে পরে করে দিচ্ছি, তুই প্লিজ এক্ষুনি জানিয়ে দে। ঠিক আছে, রাখছি। হ্যাঁ। Hello students, can you hear me?
Yes, ma'am.
Yes, ma'am.
নিলয় আর প্রসূন ক্লাসে আছো? তোমাদের সিআর? নিলয়, প্রসূন, কেউ ক্লাসে আছো? তোমাদের সিআর কেউ ক্লাসে আছে? আছো কেউ? 2 সিআর এর মধ্যে কেউ, 2 বা 4 কে তোমাদের সিআর? আমি তো শুধু প্রসূনের সাথেই জানি, আর একবার নিলয় ফোন করেছিল, এছাড়া আর কেউ সিআর আছো? আমি যদি কোনো সিআর কে অ্যাটেন্ডেন্সের ইয়েতে দেখতে পাই অথচ তোমরা কথা বলছো না, আমি কিন্তু দুজনকেই পানিশ করব। তোমরা ভুল ভাল মানে টিচারদেরকে ইনফরমেশন দাও। এবার টিচার মানে আমার নিজের কোনো দোষ নেই, অথচ মানে কি বলবো, একজন এক্সটার্নাল টিচার, আমি বারবার বলেছি যে ওনার সাথে তোমরা ঠিক করে কথা বলবে, ঠিক করে কথা বলবে, ওনার এটা একটু আলাদা। তোমরা আমাকে জানালে যে আজকে ক্লাস নিতে, আর এখন এক্সটার্নাল টিচার ওখানে বসে আছেন তোমাদের ক্লাস নেওয়ার জন্য। তোমরা এক্সটার্নাল টিচারকে ইনফর্ম পর্যন্ত করোনি। এগুলো কি বলো তো, সেকেন্ড ইয়ারে উঠে গেছো, এত দায়িত্ব জ্ঞান হলে হলে কি করে হবে তোমাদের? এর এক্সপ্লেনেশন তোমরা আমাকে অন্তত লিখিত দেবে। যদি শিয়ার নাও থাকো, যা যে এমনি ইন্ডিভিজুয়াল স্টুডেন্ট আছো তারা কথাটা শিয়ারদেরকে কনভে করবে, ওরা যেন লিখিত আমাকে একটা অ্যাপোলজি লেটার পাঠায়। বিনা কারণে তোমরা আমাকে ইয়ে করলে। শুনতে পেলে?
Yes, ma'am. Shona.
Yes, ma'am.
Okay. Let us start today's class regarding Water Resource Engineering 1. This is basically your syllabus. We will cover obviously the introduction, what is the role of hydrology in engineering, then hydrological principles, water cycle, water losses, etc. Different hydrological data, how we will measure those data and how we will deal with those data. Then estimation of stream discharge, and also we will discuss in this class the groundwater hydrology. Okay, now you know that we are having the NB accreditation, so therefore the course outcome of this class actually understand global water budget, water resource of India, and estimate stream discharge, and define and describe hydrological cycle and different functional elements of hydrological cycle, explain role of hydrological cycle in engineering, including the instruments and methodologies for hydrological data measurement and methodologies for analysis, and then assesses groundwater flow behavior and calculate aquifer parameters and able to deduce well hydraulic parameters. Okay, these are the three course objective of this class. Now out of this three course objective, actually I will discuss the global water budget, water resource of India. Then I will discuss various pathways of the hydrological cycle up to evapotranspiration and infiltration, evaporation, etc. And also I will discuss the groundwater hydrology. And Professor Eshen Mukherjee will discuss the stream discharge management and runoff, and also the flood measurement and control. Okay, so this is your syllabus basically, and I have 60 marks and of my part, and SNM sir has 40 marks. So let me first discuss the composition of earth. You all know that our mother earth basically consists of atmosphere, hydrosphere, biosphere, and lithosphere. Now lithospheres means the solid material present within the earth. Then hydrosphere basically relate to the water on the surface of the earth, in the atmosphere, and even within the lithospheres also. then all the gases uh, forms the atmosphere, and the living organisms or the surface of the earth basically result in the biosphere. Now you all know that no organisms can live without water as well as your air. Air means oxygen here. Okay, so here therefore hydrosphere is very important for us. And hydrosphere basically comes from Greek hydron, water, and spira, sphere in physical geography describe the combined mass of water found on, under, and over the surface of the earth. I already have told you that water means not only the surface of the earth, but water within the groundwater, within the soil pores, and also in the water vapor in the atmosphere. All basically forms the hydrosphere. Okay. Now, therefore, the total mass of Earth's hydrosphere is about 1.4 into 10 to the power 18 tons, which is about 0.023% of the Earth's total mass. Okay. Now, if you see the volumetrically, then the volume of hydrosphere is around 1386 million kilometer cube. Okay, but it is renewable resource, though the total amount is always same, 1386 million kilometer cube. Okay. Now the water means the water includes, already I have told that water includes in, on, under, and over the surface of earth. That means water in the ocean, lakes, rivers, wetlands, polar ice caps, soil, rock layers beneath earth's surface, as well as within the clouds. Now, of this total water, this is the volumetric representation of the water, and this is the total mass of water. Okay. Now, of this water, 0.001%, that is around 20 into 10 to the power 12 tons of water, are found in Earth's atmosphere as water vapor. Now, I already have told you that our earth is mostly water. Even from your childhood also you know that total surface area of earth is mostly the surface area of is covered by the water. Okay, and total surface area of earth is 510 into 10 to the power 16 square kilometer. Now, surface area of oceans, therefore, 361 into 10 to the power 6 square kilometer. That is 3/4 of the Earth's surface is covered by the ocean. Okay, and only remaining 1/4 is covered by land, and it is 149 into 10 to the power 6 square kilometer. But though around 71% of the total Earth's surface is covered by the ocean, but the distribution of ocean and seas are not uniform in northern hemisphere and southern hemisphere. You will find that the most surface area of the southern hemisphere is covered by the ocean and seas. You can see that 81% of the southern hemisphere is covered by the ocean, where for northern hemisphere 61% of the area is covered by mostly hydrosphere. Okay. Now, as already I have told you that total area is, total volume of the earth is 1386 million kilometer cube. Okay, but of this total water, saline
water is 97.2%. That is, most of the water is saline in nature. You cannot consume that without desalination process, and desalination is very costly and energy demanding process. Okay, and only 2.8% of the total water is fresh water, and this fresh water presents as groundwater as well as surface water. 0.06% of the total water is groundwater, and 2.2% of the total water is present as surface water. Okay, but surface water doesn't mean that it present in rivers, lakes, etc. Of the surface water, most of the water are present as ice in glaciers. 2.15% of the total water basically present as ice in glaciers. Okay, and it basically result in surface water during a non-monsoon period for the perennial type of rivers. Then water vapor, 0.04% of the total water are present as water vapor in the atmosphere, and only 0.01% of the water are present in rivers and lakes, which you can directly use. Okay. Now, whatever I have told you, I have shown you here in pie chart that I already have told you that oceans basically consist 97.2% of the total water, which cannot be consumable without desalination, and only 2.8% water is fresh water. But all the fresh water cannot be consumable because most of the water are present in the glaciers as ice caps. Okay, and 0.06% of the water are present as groundwater, and only 0.01% of the water is present in different stream channels, lakes, ponds, etc. Now, if you see the surface water distribution, then you will find that lakes basically hold 0.017% of the total surface water, and streams hold 0.0001% of the total water. So that water can be extractable. But the water in the soil, as soil moisture, as human we cannot extract that water, only vegetation can extract that water. And the water in the atmosphere, if precipitation will occur, then only water will come to as surface water. Now, if we convert the previous percentages of the world's water in the scale of 100%, then you will find that fresh groundwater is 10.5 million kilometer cube. Your total water resource is 1386 million kilometer cube, of which 10.5 million kilometer cube is present as groundwater, 91,000 kilometer cube are present as lakes, 2,100 kilometer cube water is present as river. This water can be extractable but not 100%. And 24.1 million kilometer cube water are present as ice and snow in the glaciers. Okay. So this is the basically the global water resource. Now, if we see the water resource of India as per the data of Central Water Commission 2015, sorry, India accounts 2.45% of the world's surface area. I already have shown you that total surface area of the earth is 510 into 10 to the power 6 square kilometer, and 2.45% of this land surface is in India. Okay, and of the 1386 million kilometer cube water resources, 4% water is present in India. Okay, now if you multiply the total surface area of India and the average precipitation in India is 117 centimeter. Okay, so if you multiply the total surface area of of India with 117 centimeter, the height of the precipitation, then you will find that total water available in India from precipitation is around 4,000 billion cubic meter. Okay, this is our water India obtain in each year on an average. Okay, and but you can see here, though India has only 2.45% of the world's surface area and 4% of the world's water resource, but 16% of the global population resides in India. Okay, so obviously you can understand that in terms of land resource and in terms of water resource, India has a lack of resources, and you know that we have census in each 10 years. Okay, now we had census in 2011, but in 2021 maybe due to the pandemic situation there was no census. Okay, but if we I have basically projected the population of India in 2011. Then I have obtained the projected population in 2016 is around 132 billion. Okay, 132 billion or 132.5 billion, you can say. Now, I told you already that if you multiply the total surface area by the precipitation, you will get the total volume of the water from precipitation. Now, but all the precipitation, when I will discuss the hydrology, you will find that all the precipitation cannot result in the natural flow of water. Okay, most of the cases the precipitated water again evaporated back to the atmosphere. Okay, so of this 4,000 total precipitation, 1,869 billion cubic meter per year are now available in terms of natural flow. Okay, natural flow means flow in the rivers, stream channels, as well as groundwater flow. Okay, but you know that for the stability of the soil as well as for the sustainability of the aquatic environment, all the water cannot be extractable. Okay, all the 1,869 billion cubic meter water cannot be extractable, so only usable water is 1123. So you can see that your water resource is 4000 from precipitation, but you can consume 1123 billion cubic meter if the full infrastructure is available to you. Okay, if full infrastructure of water extraction is available to you. Now, this usable water, surface water, in terms of surface water, it is around 690 billion cubic meter, and in terms of groundwater, it is 433 billion cubic meter. Okay, now of this usable water, if you divide all the usable water by the population, you will find the per capita annual water availability is 848.078 cubic meter. Okay, if you divide this value by the population, then you will have this value. Now, United Nation Environmental Protection Agency, UNEP, has classified all the countries in three classifications. Okay, one is water stressed country. That means per capita water availability is less than 1700 cubic meter per year. Okay, if for a country per capita water availability is less than 1700 cubic meter per year, then those countries are known as water stressed country. Then water scared country. That means per capita water availability is less than 1000 meter cube per year. Okay, and water famine country. That means per capita water availability is less than 500 cubic meter per year. Okay, so therefore from this data you can understand that per capita annual water availability considering the population in 2016 is less than 1000 meter cube per year. Okay, less than 1000 meter cube per year. So presently our country is water scared country. Okay, water scared country, but in near future it will not become water famine country. Okay, water famine country. So we should, and you also know that total water availability is constant, 1386 million kilometer cube. It may present in any form, maybe gaseous, maybe liquid, or maybe solid form. Okay, but fresh water availability is also constant. So if we have even scarcity of the fresh water, now even if we anthropogenically pollute the fresh water resource, then obviously the percentage of the fresh water will be reduced, since the total water availability is always same. Okay, so that is why we have to judiciously use as well as conserve our natural water resources. ওকে, এই পর্যন্ত কারো কিছু বুঝতে অসুবিধা আছে?
Ma'am,
হুম
আপনি বলেছিলেন যে আমাদের যে ফ্রেশ ওয়াটার রিসোর্স আছে সেটা কনস্ট্যান্ট আছে, আর ওটাই আমরা লাইক ড্রিঙ্কিং পারপাসেস এর জন্য ইউজ করতে পারি।
সবকিছুর জন্য, যেখানে যেখানে ফ্রেশ ওয়াটার ইউজ করবে সবকিছুর জন্য।
কিন্তু ম্যাম ওয়াটার একবার ইউজ হওয়ার পর তো লাইক যখন আমরা ওটা এক্সপ্লিট করি ওটা তো লাইক ওটা কি তার রিনিউ করা হচ্ছে না তো টেকনিক্যালি, না ওটা লাইক
হচ্ছে না তো। আরে আমি এটা তোমাদেরকে বলবো তো, ওই জন্যই তো আমি বলছি যে এবার দেখো তোমার টোটাল ফ্রেশ ওয়াটার রিসোর্সেস সেম, ওটা ধরো আবার মানে ধরো আইদার তুমি কি বলবো, আইদার তুমি ল্যান্ড ডিসচার্জ করছো অর রিভার ডিসচার্জ করছো পলিউটেড ওয়াটার, ঠিক আছে? ওটা আবার সেল পিউরিফাইড হয়ে আবার তোমার রিসোর্সে ঢুকে যাচ্ছে।
প্রেসিপিটেশন হয়ে আবার।
হ্যাঁ,
আচ্ছা আচ্ছা।
প্রেসিপিটেশন নয়, হ্যাঁ
সি
প্রেসিপিটেশনও
থেকে
বলতে পারো।
সি থেকে ওয়াটার ইভাপোরেট করে
ধরো
এসে আবার
ধরো তুমি,
রেনফল হয়ে আসছে।
হ্যাঁ ধরো তুমি ল্যান্ড ল্যান্ড ডিসচার্জ করেছো, ঠিক আছে? তাহলে ন্যাচারাল ল্যান্ড রিক্লামেশন হচ্ছে, সেটা আবার গ্রাউন্ড ওয়াটার হচ্ছে, আবার তুমি নিচ্ছ। বা যদি তুমি রিভার ডিসচার্জ করো, ওটা গিয়ে সমুদ্রে পড়ছে, এভাপোরেটেড হচ্ছে, আমি এগুলো আবার সবকিছু আবার দেখাবো, তাহলে আবার প্রেসিপিটেশন হয়ে তোমার আবার তোমার কাছে চলে আসছে, ঠিক আছে? এটা যদি এক্সেসিভ না করো তাহলে ঠিক আছে,
ওকে আচ্ছা।
কিন্তু কেন কি, যদি 2.8%টাকে তুমি না হ্যাম্পার করো দেন ওকে, কিন্তু সেটাই তো আমি বলছি। কিন্তু আমরা কি করছি, অ্যানথ্রোপোজেনিক্যালি আমার যতটা ইউজ করার কথা, এমনিই দেখতে পাচ্ছ পপুলেশন বাড়ছে, যদি আমি এটাকে পলিউট না করি, তাও অনলি পপুলেশন বাড়ার জন্য আমার পার ক্যাপিটা অ্যাভেলেবিলিটি কমে যাচ্ছে, তাই তো? লোক বাড়ছে, ওয়াটার রিসোর্স তো তোমার সেম। কিন্তু তার সাথে যদি আমি ধরো অ্যানথ্রোপোজেনিক্যালি প্রেসিপিটেশনটাকে হ্যাম্পার করি, বা এই ফ্রেশ ওয়াটারটাকে তুমি ধরো ওভার এক্সট্রাকশন করে যদি পলিউট করো, বা নানা রকম ইন্ডাস্ট্রিয়াল ডিসচার্জ করে যদি পলিউট করো, তাহলে 1123টাও তো কমে যাচ্ছে, তাই না? সেই জন্যই হচ্ছে ইয়ে। আর কিছু
অ্যানথ্রোপোজেনিক্যালি ওয়ার্ডটার একটু মিনিংটা আমায় বলবেন ম্যাম?
অ্যানথ্রোপোজেনিক্যালি মানে হচ্ছে মানে বাই ম্যানুয়াল action if you pollute the water. For example, I don't know whether you have heard or not that most of the water aquifer in Gangetic Plain region are affected by arsenic, okay? Or in Bankura, Purulia, Birbhum, they are affected by fluoride. Okay, why? Because it was already in the lithosphere, okay, but at that time it was in stable condition. But whenever you are over extracting the groundwater, you know that the soil pores are filled with air and water. Okay, soil pores are filled with air and water. If it is saturated, then it is completely filled with water. If it is partially saturated, then partially water and air. And if it is unsaturated, then fully fully filled by air. Okay, now if you over extract the water, so these pores will now filled with the air. So air means oxygen, and therefore it will oxidize the arsenic as well as fluoride present in the lithosphere, which was in the unstable stable condition. But whenever it is oxidized, it will dissolve with the groundwater, and you are now getting the polluted arsenic laden or fluoride laden water. So you are basically anthropogenically pollute the fresh water resources.
Understood, ma'am. Understood.
Now, as already I have told you that for the stability, you cannot extract the total groundwater as well as total surface water. If we consider the groundwater resource of India given by Central Groundwater Board 2016, then you will find that in this table I have to shown you that total groundwater availability is 433 billion cubic meter. Okay, but you cannot extract all that water. you can extract only 398 billion cubic meter water for different development purposes. Now, remaining 35 billion cubic meter of natural discharge are utilized for maintaining flow in springs, rivers and streams during non-monsoon period. Okay, when there will be no precipitation, you may find still some water in the streams, rivers, lakes, etc. These are due to the natural discharge from the groundwater, okay, which is known as subsurface flow. Now, groundwater, if the total infrastructure is present, then we can extract 398 billion cubic meter. Okay, but we don't have so much infrastructure, so in India we only can extract 231 billion cubic meter of water. Okay, so therefore our groundwater development is total the groundwater draft means groundwater extracted divided by the total replenishable resource. So 231 by 398, that is 58%. Okay, all the groundwater, though 398 billion cubic meter can be extracted, but due to our lack of infrastructure, we only can extract 58% of the groundwater resource. And you know that our country basically depends on irrigation, so therefore most of the groundwater, that is 89% of the extracted water, are utilized for irrigation purpose, and only remaining 11% of the groundwater is used for domestic purpose and industrial purpose. Okay, now I already have told you that your total extractable water is 1800 billion cubic meter per year, of which 150 billion cubic meter is stored in different reservoirs, dams, etc. And you can see 1500 billion cubic meter water is goes to the sea and adjoining countries. For example, you know that the water from our through our river goes to Bangladesh. Okay, so then therefore only utilizable water through diversion works and direct pumping is 150 billion cubic meter. So though you have resources, but due to lack of infrastructure, we cannot use all the water. Most of the water goes to sea and the adjoining countries. Now, if you see the river water resource in India, then you know that our country is very much dependent on river, and rivers are the lifeline of growth and culture. And there are 12 major river system along with a number of small rivers and streams in India. Okay, and for northern India, most of the rivers are perennial in nature. That means water is obtained from the glaciers, so you can obtain water throughout the year, like Ganga, Jamuna, Indus and Brahmaputra. But for South India, the mostly the rivers are non-perennial type. That means they are fed from the precipitation, like Krishna, Godavari and Kaveri. And in central India, all the river in central India are also the precipitation dependent river. They are, that is non-perennial type. They are Narmada, Mahanadi and Tapti. And the Ganges, Brahmaputra as well as Indus system are the largest river system of India, as they drain almost half of the country, carrying more than 40% of the utilizable surface water from the Himalayan watershed to the ocean. Okay. And 70% of the India's river basically drain into the Bay of Bengal, and remaining 20% are drain to the Arabian Sea, mostly from the Indus and other river. And 10% of the river drains into interior basins, means land area, and natural lakes. Okay, now you already know that because of our indiscriminate use of different types of toxic pollutants, our most of the rivers are now polluted. Okay, so because of this, I don't know whether you have heard about the Ganga Action Plan, the Jamuna Action Plan, because in your fourth year class you will read that you will read about the water quality. Okay, our river are mostly should be of water quality which is acceptable for bathing purpose. Okay, bathing purpose, but in reality you will find that most of the rivers are polluted because of the greed of the residents. Okay, so that is why since your total water availability will be always constant, so you should be very much cautious about the water resource, so that you can conserve the water resource, because most of the diseases of human as well as the living organisms are waterborne disease. ওকে, এই পর্যন্ত আরো কোনো কোয়েশ্চেন আছে তো বলো। So this is all about the water resource of world as well as India. Now let me discuss you the origin of water. There are various theories regarding the origin of water. Most commonly used theories are degasification theory and collisions with comets. According to degasification theory, water vapor, carbon dioxide, carbon monoxide, methane, ammonia, sulfur, hydrochloric acid, argon, hydrogen came to earth during lava degasification, resulting into water. Okay, and since you can see that water contains different acids like CO2, since these CO2, then sulfur, hydrochloric acid, so if they dissolute in water, so they forms acid rain. Okay, acid rain means the pH, generally the pH of rainwater is 5.63, because of the presence of dissolution of carbon dioxide. Now if it is less than 5.63, then it is known as acid rain. Now since sulfur, ammonia as well as hydrochloric acid are dissolute in water also. Therefore, it reduces the pH and it becomes acid rain. And because of the acid rain, the alkaline earth was formed. And you know that most of our earth, that means soil, is alkaline in nature. So this is one of the theory of related to origin of water. And another theory is collisions with comets. Okay, collision with comets. According to this theory, the early Earth was subjected to a period of bombardment by comets and water-rich asteroids. Okay, and much of the water on the surface today is thought to have originated from the outer parts of the solar system, such as from objects that arrived from beyond Neptune. Okay, these are the two theories related to the two commonly used theories related to the origin of water. Now come to our main syllabus, that is hydrology. What is hydrologic cycle actually? I already have told that during hydrosphere I have told that it is basically consist of two Greek words. And then hydrology is also consist of two Greek words, hydor plus logos. Hydor means water and logos means study. Okay, and hydrology is therefore a science which deals with the occurrence, circulation, and distribution of water of the earth and earth's atmosphere. Okay. As this is basically a branch of earth science which is concerned with the water in streams and lakes, rainfall and snowfall, snow and ice on the land, and water occurring below the earth's surface in the pores of the soils and rocks. I already have told you that hydrosphere doesn't mean the water on the earth's surface only, but it also includes the water below the earth's surface, within the pores of soil and rocks, and also in the atmosphere. And this hydrology is a very broad subject of interdisciplinary nature. Okay, which draws support from physics, chemistry, mathematics, statistics, geology, meteorology, fluid mechanics, etc. Now, hydrology is basically a applied science. Okay, and hydrology is divided into two branches. One is hydrological science and one is engineering hydrology. Hydrological science means the study which is concerned chiefly with academic aspect of the subject. Okay, and engineering hydrology means, you know, that it is the application of the hydrological science. So is basically concerned with the engineering application of the hydrological science. And in this engineering hydrology is basically deals with the estimation of the water resources, the study of different processes, the study of different processes related to hydrological cycle? Like precipitation, evaporation, infiltration, etc., and their interactions. And lastly, problems like drought, flood, etc., and how to combat them. Okay, so in this class, I will basically discuss about the engineering hydrology. Okay. What is therefore hydrological cycle? Water occurs on the earth in three states. You all know that, like liquid, solid, and gaseous, and in various degrees of motion. Okay. And evaporation of water from water bodies, then formation of cloud, stream flow, etc., are dynamic aspect of water. Okay. Now, therefore, hydrological cycle, which is also known as water cycle, also is a continuous movement of water on, above, and the surface. Okay. Change of heat energy, which leads to the temperature changes also. You understand that since water present in three forms: liquid, solid, and gaseous. So to change from one form to another form, it requires energy, as well as it can emit energy, which led to the temperature changes also. And this is basically the schematic representation of the hydrological cycle. Okay, this is basically a schematic representation of hydrological cycle. And you know that to cover the hydrological cycle, there should be a source of energy. So sun is considered as the source of energy of the hydrological cycle. Okay, now and this is basically a circular. It is constant circular path. Okay, so it has neither any well-defined beginning nor any end also. But it is convenient if we start from the evaporation in the evaporation from the ocean. Okay. So if water of the ocean evaporates due to the energy provided by the sun. Okay. Now this evaporated water is moves upward and cools
Ma'am, your voice is gone. We cannot hear it anymore.
sufficient amount of nucleus are present. So if favorable conditions are there, then these clouds will cause precipitation above the ocean. Are carried to the
Ma'am, your voice
surface.
is cracking.
Okay. Voice is breaking.
Yes, ma'am.
So
Yes, ma'am.
but I am showing the full internet here. Anyway, so it is
Actually, ma'am, sometimes
the
his
clouds are
voice is going
taken to.
on. It's okay. Okay, now it's.
Now in the hilly region it precipitated as snowfall, and in the plain region it is precipitated as rainfall. Okay. Now during precipitation some of the water are evaporated back to the atmosphere. Again it will cool adiabatically and forms clouds. And before reaching to the surface, some of the precipitations are intercepted by the vegetation. Okay, intercepted by the vegetations as well as structures. If buildings are there, they also intercepted some of the precipitation. Okay, and that intercepted water again reaches to the atmosphere as water vapor. And after the fulfilling the demand of the interception, the water then reach to the ground surface. Okay, reach to the ground surface. Now some of the water are infiltrated, then percolated and reach to the groundwater table. Okay, reach to the groundwater table. And some of the soil moisture are extracted by the water uh, evaporated to the atmosphere. কিছু করার নেই, আমার ইন্টারনেট কখন কি আসছে, তবে আমি যখন তোমাদের যদি কোথাও ব্লার থাকে আমি ওটা ঠিক করে পাঠাবো, ঠিক আছে? আপাতত শোনো, আমি তো ইন্টারনেটে কিছু করতে পারবো না, না? আমি যখন তোমাদের পাঠাবো, আই উইল ট্রাই যাতে ব্লার ভয়েস থাকলে সেটা যাতে আমি রেকটিফাই করে দিতে পারি।
Okay, ma'am.
So that is known as transpiration. Now the precipitation reaching the ground surface. Here you can see the precipitation reaching the ground surface after meeting the demand of infiltration and evaporation moves down the natural slope. You can see that it moves down the natural slope over the surface and through a network of gullies, streams and rivers to reach the ocean. Here you can see then it through the rivers. First it will fulfill the natural depressions, and then through the channels of the river it basically falls in the ocean. Okay, now the groundwater may come to the surface. This groundwater, which is now in the water table, come to the surface through springs and other outlets after spending a considerable longer time than the surface flow. Okay, now the portion of the precipitation which by a variety of path above and below the surface of the earth reaches the stream channel is known as, here you can see that some of the water are follows the natural slope above the ground, and some of the water are follows the path below the ground. Okay, so this is additively known as runoff. Okay, this is known as surface runoff, and this is known as subsurface runoff. Okay, and once it enters a stream channel, once it enters the stream channel, it becomes stream flow. Okay, and finally through these stream channels it falls on the ocean again, and again it will be evaporated and then cool and then form clouds. Okay, the sequence of events as shown in the picture is a very complex cycle that has been taken place since the formation of the earth, and this is known as hydrological cycle, and it is very vast and complicated cycle with large number of paths. Here you can see different paths they are following, like evaporation, precipitation, transpiration, surface runoff, infiltration, etc., and of varying time scale. Okay, and it is a continuous recirculating path. It is continuous recirculation path. That means it has neither any end or nor any beginning or nor any pause also. And all the path of the hydrological cycle involves three things. All the path of the hydrological cycle involves three main things. One is change of state. Okay. Number two is transportation. And number three is change of state, transportation, and temporary storage. Here you can see that evaporation means what? Evaporation means change of state and transportation. Then formation of cloud means change of state, transportation, as well as temporary storage. Then if you consider the groundwater, then it is temporary storage and transportation. So all the paths are basically consist of three things. One is change of state, transportation, and temporary storage. Okay. Now the quantities of water going through various individual paths of the hydrological cycle in a given system can be described by a continuity principle. Okay. Continuity principle. I will discuss what is continuity principle, which is known as water budget equation. And I am repeatedly telling that the total water resource of the earth is constant. Okay, and sun is the source of energy. So, a recognition of various processes such as evaporation, precipitation, transpiration, groundwater flow helps us to study the science of hydrology in a systematic way as well as to conserve our water resources. Okay, but you can see that man can interfere any part of the hydrological cycle. Okay, how? They can form precipitation artificially, known as artificial rain. Then they can suppress the evaporation by adding chemicals. Okay, then change of vegetation cover as well as land use pattern. They can over extract the groundwater resources. Okay, so but if there is any interference occurs at any stage, then it can cause serious repercussion to some other stage of the cycle. Okay, that you should consider. And you should always consider that if you influence any of the pathways of hydrological cycle, then it will influence in a variety of fields including agriculture, forestry, geography, economics, political science, sociology, etc. Okay, so therefore, another thing you should consider that all these various paths are basically involves different time scales. Okay, with different time scales, and which is known as the residence time, which is known as the residence time, means the average duration of a water particle to pass through a phase of the hydrological cycle. That means the time to overcome the water particle from the ocean stage to the cloud formation is known as the residence time for evaporation. Okay, and less the residence time, more will be the uncertainty involves. Less the residence time, more uncertainty will be there. Okay, now how we will calculate the residence time? As I already told you, the average duration of a particle of water to pass through a phase of the hydrological cycle, and these are different phases of hydrological cycle I already have discussed. So if you see the global water resource, then you will find that the volume of water in the river of the world is 0.00212 million kilometer cube. Okay, and average flow rate of water through global river is 44,700 kilometer cube per year. So if you divide the total volume of water by the average flow rate of water, you will find the residence time of global river. Okay, your flow rate is X and your total volume is V. So if you divide V by X, you will get the residence time. And for global water, the residence time is 17.3 days. Okay, and less the residence time, more will be the chance of the uncertainty. এই পর্যন্ত কারো কিছু কোয়েশ্চেন আছে রিলেটেড টু হাইড্রোলজিক্যাল সাইকেল?
And can you go to the next page for 1 second? Yes, ma'am, লিখে নিচ্ছি। Thank you.
Now come to the very important thing of hydrological cycle, that is water budget equation. Now before discussing the water budget equation, I should define what is watershed area or catchment area. Watershed or catchment area. Sorry. The area of land draining into a stream or a water course at a given location is known as catchment area. Here you can see this is the catchment area of the river. Okay, that means whatever precipitations is occurred within this area are drained through this river. Okay, and it is also known as the drainage area or drainage basin. Now catchment area is utilized in UK and watershed area is generally utilized in USA. Okay, and a catchment area is separated from its neighborhood area by a ridge called divide in USA and watershed in UK. Okay, this is the catchment area of river A. Now there may be another adjacent catchment area of another river. So these two catchment areas are divided with a ridge known as ridge line for known as divide in USA and watershed divide in UK. Okay, and the areal extent of the catchment is obtained by tracing. How you will get the areal extent? Okay, so you will obtain the areal extent by tracing the ridge on a topographic map, and then you will measure it by a instrument known as planimeter. Okay, so you now understand what is watershed as well as catchment area. Now for a given catchment area, for a given time interval, the continuity equation for water is applicable in various phases of the hydrological cycle. Okay, continuity equation means principle of continuity of mass, means mass input minus mass output is equal to mass storage. Okay, now for a particular catchment area, for a particular time interval, if you consider various parts of the hydrological cycle, then you will find that if, let us consider this is your catchment area. So if you consider all the input and if you consider all the output, and there will be some storage here. So for this boundary area, that means catchment area, the mass of input minus mass of output is equal to mass of storage. Okay, and you know that for a particular temperature, the density of water is always constant. Okay, density of water is always constant, so you may divide, you can consider that the density of input, output and storage are same. So if you divide the mass by the density, so you will get the volume input minus volume output as is equal to volume of storage. Now the catchment area is constant. So therefore, if you divide all the volume by the area, so you will get height input, height of output is equal to the height of storage. Okay, for example, I don't know whether you have read today's newspaper or not. You may find that yesterday they are assuming that you know the aerial extent of Kolkata. Aerial extent of Kolkata multiplied the height of the precipitation, so you can know the volume of water in Kolkata yesterday. Okay. Now, the water budget equation for a catchment area in time interval del t can be written as precipitation. Precipitation, you know, the inflow minus the runoff minus evaporation minus transpiration minus infiltration minus interception loss is equal to change of storage. Okay, is equal to change of storage del S. Now, the storage consists of three components. One is surface water storage in lakes, ponds, etc. One is which is denoted by SS. Then water storage in groundwater table, so SG, as well as water storage as soil moisture. Okay, from which we cannot extract, human cannot extract the water, but vegetation can extract water from the surface storage, soil moisture storage. Okay, now you know that here the all the expressions which I have considered may be expressed either in terms of volume or in terms of the height if area is known to you. Okay, now you know that our major concern is basically the runoff, because this is the utilizable water. Okay, we are basically concerned about the runoff. So therefore, we can write all the other things except runoff are as the loss to the precipitation. Okay, all the other things like evaporation, transpiration, infiltration, interception loss, surface storage, as well as the soil moisture, these are not included in your runoff. So they may be considered as the loss. So runoff is equal to precipitation minus loss. Okay, and then you can calculate the runoff coefficient as runoff divided by the total precipitation. So if you know the runoff coefficient of a particular area, you can understand that how much precipitation will be available as runoff. So water budget equation is clear to you. This is very important for the study of water resource engineering. ঠিক আছে? Now, for better understanding, let me explain one problem. A lake had a water surface elevation of 103.2 meter above datum at the beginning of a certain month. Okay, you know, you already have learned the survey, and you know that the elevation of a particular area are expressed with reference to some constant elevation, okay, which is known as datum. So the lake had a water surface elevation of 103.2 meter above datum at the beginning of a certain month. Now in that month, the lake received an average inflow of 6 meter cube per second from surface runoff sources. In the same period, the outflow from the lake had an average value of 6.5 meter cube per second. Okay, you have a lake. You have, at the beginning of a month, you have a average inflow 6 meter cube per second and average outflow 6.5 meter cube per second. Okay. Now further in that month, the lake received a rainfall of 145 millimeter and the 145 millimeter rainfall. Okay. And the evaporation from the lake surface was assumed as 6.1 centimeter. 6.1 centimeter is the evaporation. Write the water budget for the lake and calculate the water surface elevation of the lake at the end of the month. Okay, the average lake surface area can be taken as 5,000 hectare. Assume there is no contribution to or from the groundwater storage. Okay, so I repeat the problem again. A lake had a water surface elevation of 103.2 meter above datum at the beginning of a certain month. Okay. In that month, the lake received an average flow of 6 meter cube per second from surface runoff sources. In the same period, the outflow from the lake had an average value of 6.5 meter cube per second. Further in that month, the lake received a rainfall of 145 millimeter and the evaporation from the lake surface was estimated as 6.1 centimeter. Write the water budget equation for the lake and calculate the water surface elevation of the lake. Let us consider this is Now the water surface elevation 103.2 from the datum. Now after the end of the month, whether the water surface elevation will be move upwards or whether it will move downwards, that you have to determine. And the areal extent of the lake was given as 5,000 hectare, and assume that there is no contribution to or from the groundwater storage. Okay, so this is your problem. Now, you know, I am telling repeatedly that whenever you will discuss anything about related to the water resource engineering, hydrological cycle, you always have to mention the areal extent as well as the time interval. Okay, so I already have told you that for a time interval del t for the lake, the water budget equation will be input volume minus output volume is equal to change in storage of the lake water. Okay. Now input means the inflow multiplied by del T plus the precipitation multiplied by the areal extent. Okay. Now outflow, rate of outflow multiplied by del T, and evaporation is also cause of another outflow. So evaporation height multiplied by the areal extent is equal to change of storage. Okay, is equal to change of storage. Now here, as time interval, they have told that it is for 1 month. Okay, it is for 1 month. So let us consider that it is of 30 days month. Okay, 30 days month. So del T will be 30 days into 24 hours into 60 minutes into 60 seconds. Okay, 2.592 million second. Now therefore inflow volume will be obviously the rate of inflow into the time interval. So 6 meter cube per second multiplied by the time interval 2.592, so 15.552 million meter cube. And outflow volume is rate of outflow 6.5 multiplied by the time interval, so 16.848 million meter cube. You will do all the problems by yourself in your home. Then input due to precipitation. Precipitation, the height was given. Okay. So therefore you have to multiply with the areal extent of the lake. And whenever you will solve this type of problem related to water budget equation, you always express all the units uniformly. Okay, all the units uniformly. So that is why your precipitation is 145 millimeter. So 14.5 centimeter divided by 100. Okay, 14.5 centimeter divided by 100 into the areal extent of the lake is 5,000 hectare. So 5,000 into hectare means 10 to the power 4 meter square. So into 100 into 100. Okay. And since the unit of the inflow volume and outflow volume are in million meter cube, so divide it by 10 to the power 6. Okay, to convert it into million meter cube. So the volume will be from precipitation, it is 7.25 million meter cube, and outflow due to evaporation is the height of the evaporation into areal extent. Now height of the evaporation was given 6.1 centimeter divided by 100 into the areal extent 5000 into 10 to the power 4, and to convert it into million you have to divide it by 10 to the power 6. So 3.05 million meter cube. Okay. Now therefore put all the values in the water budget equation. Del S is equal to the inflow from the flow surface runoff 15.552 plus inflow from the precipitation 7.25 minus the outflow from the lake 16.848 plus the outflow due to evaporation 3.05. Okay, so del S is equal to inflow minus outflow, and you have obtained it as positive 2.904 million meter cube. Okay, so since in the problem they have asked that you have to determine the water surface elevation. Okay, water surface elevation. So therefore convert the storage volume to the height. Okay, so storage volume 2.904 into 10 to the power 6 by the areal extent of the lake. Okay, areal extent of the lake. So it is 0.058. It is positive. It is positive. So therefore, your new water surface elevation at the end of the month will be 103.2 meter plus মা একবার ওই চার্জারটা অন করো তো প্লাস 0.058. Okay, so it is 103.258 meter above the data. So water elevation will be move upwards. Okay, water elevation will move upwards, but it may be downwards also. If there is more loss than gain, then it may be negative also. Okay, বোঝা গেল? How we will solve the problems related to water budget equation? Very simple problem. Always you have to just identify which will give you the inflow and which will give you the outflow. That you have to identify, and then you have to consider the time interval and the areal extent, and you have to express all the units uniformly. বোঝা গেল?
Yes, ma'am.
Yes, ma'am.
Now let me discuss another type of problem. Is small catchment of area 150 hectare received a rainfall of 10.5 centimeter in 90 minutes due to a storm. Okay, the areal extent was given to you 150 hectare and a rainfall was occurred for 90 minutes. Okay, at the outlet of the catchment, the stream draining the catchment was dry before the storm and experienced a runoff lasting for 10 hours with an average discharge of 1.5 meter cube per second. Okay, so there was a outflow from the catchment area at the rate of 1.5 meter cube per second for 10 hours. Okay. Now, the stream was again dry after the runoff event. Then what is the amount of water which was not available to run off due to combined effect of infiltration, evaporation and transpiration? And what is the ratio of runoff to precipitation? Okay, I repeat the problem again. It is a catchment area of 150 hectare and there was a precipitation for 10.5 centimeter for 90 minutes. Okay, and there was a stream through the lake, through the catchment area, and before the rain, the stream was dry. Now after rain for 90 minutes, there was a outflow 1.5 meter cube per second for 10 hours. Okay, and then the stream again dry. Then what is the amount of water which is not available to run off due to combined effect of infiltration, evaporation and transpiration? So some of the water are infiltrated, some of the water are evaporated, transpirated, etc., which not create any runoff. That means loss. You have to determine the loss as well as you have to determine the ratio of runoff to precipitation, that is runoff coefficient. Now, your input due to precipitation is the areal extent 150 into 10 to the power 4 multiplied by the rate of precipitation, that is 10.5 centimeters. So 10.5 divided by 100. It is 157,500 meter cube. Okay, 157,500 meter cube. And your runoff volume is equal to the rate of runoff 1.5 meter cube per second multiplied by time interval 10 hours. So 10 into minute into second. Okay, so it is your total runoff. So therefore losses are the total precipitation minus total runoff. That means 103,500 meter cube is your losses. And runoff coefficient is equal to total runoff divided by total precipitation. So 54,000 by 157,500. So 0.343. So this is your runoff coefficient. Okay. So in this way, you can also determine the runoff coefficient from the precipitation also. Okay, this is another type of problem. বোঝা গেল এই অঙ্কটা?
Yes, ma'am.
So to conclude, so already I have told you that hydrologic cycle is very vast and complicated cycle in which there are a large number of paths of varying time scales. And also I have told that less the time scale, more uncertainties are there. Okay. And it is a continuous recirculating cycle. That means there is neither any beginning nor an end or pause. And each path involves one or more of the aspect. What are the aspect? One is change of state, temporary storage, and transportation. Now, the quantities of water going through various individual paths in a given system can be described by the continuity principle known as water budget equation. Already I have explained. Now, total water resource of Earth is constant, 1386 million kilometer cube, of which only 2.8% is fresh water, and all the fresh water cannot be extractable, you know that. And the sun is the source of energy. And man can interfere with virtually any part of the hydrologic cycle, either through artificial rain, evaporation, suppression, change of vegetal cover, and land use pattern, groundwater extraction also. And I have told that if they will influence any of the pathways of hydrologic cycle, then it will create interference to other paths also, and it create problems to the not only the water resources but also socio-economic issues, political issues, then irrigation, then navigation, water supply, etc. Okay. Now it will influence the any interference in water hydrological cycle will influence the agriculture, forestry, geography, economics, sociology, political conditions. And why it is important to study the hydrologic cycle or water resource engineering? Because it deals with the design and operations of projects related to irrigation, navigation, water supply, flood control, hydropower, etc. Okay, so therefore water resource engineering is very important subject throughout your civil engineering course. You will have to read irrigation, then transportation engineering, which is related to navigation. Then water supply is very important part of the civil engineering, you know. And also by reading this subject, you will you will study the different problems related to water resources like flood, drought, etc., and how to control them. And it will also related to renewable energy like hydropower. Okay, so this is the end of the today's class. I will just show you some of the references I have utilized to prepare my slides. আর কারো কিছু কোয়েশ্চেন থাকলে তোমরা বলতে পারো। So different books are available related to hydrology. Any book you can consider. Commonly used book is Subramania K, Engineering Hydrology. Okay. Or you can also take Raghunath, then Garg. The book of Garg is also very common. Then for groundwater, you can use Groundwater Hydrology by Todd. You can adopt any book what is available to you. Okay, so these are different books actually I have considered to prepare the slides of water resource engineering. ওকে, বলো কারো কিছু কোয়েশ্চেন থাকলে বলো, আমি এখন অ্যাটেন্ডেন্স নিচ্ছি। আর অ্যাজ অলরেডি আমি তোমাদেরকে বলেছি যে আজকে যা হয়ে গেছে হয়ে গেছে, তোমাদের 2 সিআরকে একটা অ্যাপোলজি লেটার লিখতে বলবে। আর নেক্সট উইক থেকে হচ্ছে ইয়ে করবে, আমি শনিবার ক্লাস নেব যতদিন পর্যন্ত ইয়ে হবে, মানে অনলাইন ক্লাস হবে ততদিন, কম্বাইন্ড হবে ততদিন আমি শনিবার নেব, তারপর অফলাইন ক্লাস হয়ে গেলে তো আর কম্বাইন্ড নিতে পারবো না, তখন তোমাদের যেরকম রুটিনে আছে সেভাবেই ক্লাসটা হবে। বলো কার কি সবকিছু কোয়েশ্চেন আছে আজকের ক্লাস নিয়ে বা অন্য কিছু নিয়ে?
No, ma'am.
ধরো 1 সেকেন্ড, অ্যাটেন্ডেন্স নিচ্ছি তারপর বেরোবে। আর যে প্রবলেমগুলো আমি বোঝাচ্ছি, আমি তো এখানে তোমরা সঙ্গে সঙ্গে করতে পারলে ভালো, আর যদি এখানে করতে না পারো তোমরা বাড়িতে সবাই হাতে প্র্যাকটিস করবে এই প্রবলেমগুলো। কেন কি হাইড্রোলজি বা ওয়াটার রিসোর্স ইঞ্জিনিয়ারিং আমি এক্ষুনি বললাম ভীষণ ইম্পর্টেন্ট সাবজেক্ট হচ্ছে সিভিল ইঞ্জিনিয়ারিং। ফর সিভিল ইঞ্জিনিয়ার্স ইট ইজ ভেরি ইম্পর্টেন্ট সাবজেক্ট। এ হিউজ পোর্শন অফ দ্য questions of GATE comes from this subject, as well as if you have knowledge in this subject then it will be easier to cope up with other related subject. There are lots of other related subject. I already have told you irrigation engineering, water supply and wastewater management, how we will design those systems, then hydrological structure. There are lots of electives related to this subject, etc. Okay, so this is very important subject. Now you may leave now, all the attendance I have taken. Next week Saturday 11টা থেকে ক্লাস নেব।